warahmatullahi, and I welcome all of you to this session of manufacturing. Okay, so we will start very soon. Okay, so again, this is not my name, so I only borrowed these slides from my colleague. Okay, so I will be using it throughout my lessons. Okay, so as far as manufacturing is concerned. Now, today's topic is going to look at the overview of manufacturing processes and then the technologies involved. So now the world is moving towards internet usage, okay, robotics, Internet of Things, and so on. So the whole manufacturing process or scenario is changing. Okay, if you look back, maybe 100 years back, the technology for manufacturing is far different from today's technology. Okay, so this topic is very, very important, especially for manufacturing industry. Okay, so the overview, first we look at the introduction to manufacturing. Okay, so the slide consists of 5 main areas. Okay, the next one will be role of manufacturing in nation economy. Sustainable manufacturing processes. Please, those of you who have on your mic, can you mute it, please, so that there wouldn't be any noise in the background. Thank you. So, industrial revolution, okay, and then virtual manufacturing. And the last one is competitiveness aspect in manufacturing processes. So when we say manufacturing, what is manufacturing? Okay, so the classical definition for manufacturing is that the process of converting more raw materials into a product. Okay, so that is the main idea of manufacturing. We want to convert a raw material into a product. For example, cocoa, if you see, there are some countries that produce cocoa, or even we can take, for example, in Malaysia here, palm oil. So there's a lot of companies that grow palm oil seed. Okay, so after you harvest the seed, you have to process it into oil, into different products like that. Okay, also it also involves activities in which the manufacturing product itself is used to make other products. For example, sewing machine to make clothing. Okay, so again, cars for traveling, for transportation, and so on and so forth. Okay, so then manufacturing is a complex activity involving variety of resources and activities. It involves product design, machinery and tooling, and then process planning, the materials, production control, support services, and marketing, etc. So all these areas, okay, come together to form a complex manufacturing processes. Some of these things, you may not be able to achieve your target product, okay? Like, for example, production design has to be linked with the machinery and tool. If you don't have the tool, there's no way you can produce your product. There is somebody in the background who has not muted his, or maybe I have to mute all of you so to avoid. Okay, so let's move on to the next slide. What is essentials? What are the essential things, elements in manufacturing? Okay, we have eight main elements or important areas in manufacturing: design requirement, product specification, and standard. Okay, so the design requirement is very important. Okay, if you want to design something like, let's say, either a car tire or internal combustion engine, or let's say a plastic cap. Okay, so you have to design it in a way that will be convenient for uh, those who will be using it to use it in a very good way. And then product specifications. What are the specifications and standard? Standard means that you need to follow a certain standard guideline, which is given by the standard board. For example, the Malaysian Standard Board, okay, always issue certain guidelines for manufacturing industries to follow. It means you cannot just wake up and start producing your product. You have to go according to the standard given by the standard board. Okay, then economical, say the product should be economical, environmental friendly. Okay, so economical in the sense that people should be able to buy the product that you are producing. So if people cannot afford, then your business will not last long. Okay, if you are producing chocolate and the chocolate, let's say, about 100 grams of the chocolate is costing about 50 ringgit. So nobody can buy. It will be in the shelf like that. So it should be economical and environmental friendly. Environmental friendly means your product should not harm the environment. For example, you all see what happened in Ango last time. Somebody was doing polluting the river. So this is not good. Okay. So then the quality of the product should be there, the flexible materials, production method, okay, then the system which is used, continuous production, product improvement. So it means that you see every company, manufacturing company, they have R&D, research and design. So they always want to bring out innovative way of manufacturing or enhancing their productivity. It is very important. And then there are types of product production, three main types. Okay, we have low quality production, low quantity production. For example, when we say low quantity production, okay, we are referring to about 1 to 100 units per year. For example, aircraft, ships, and so on. So nobody, it's not possible that you can produce aircraft for about, let's say, 10,000 aircraft per year. It's not possible. Okay, so these are what we call low quantity production. Okay, ships also. Okay, then we have medium quantity production. Okay, so it means if the number of products is about 100 to 10,000 units per year, then we consider this to be medium. Okay, for example, team just say, okay, so it could be like that. And then sometimes also bicycle, okay, bicycles also can be in the medium. And then let's say these small bicycles for children also can be in that category. Now we can also have high quantity production. High quantity production is about 10,000 to 1 million units per year. Okay, so car, maybe if you visit Proton company, they can produce about 10,000 to 500,000 cars per year. Then this is high quantity production. Okay, the product life cycle is very, very important. From the day it was produced to the day again, it is going to expire. So now, and the sales take off. Normally, we have low scale, high cost, okay, per customer, financial losses. So if you, in the introduction part, okay, during the production life cycle, between at the introduction part, this is how your financial situation is going to be. Okay, so here we have low sales, means you have not started selling your products. And then we have high cost per customer. Okay, so financial losses. So this is the initial state of the production. Innovative customers, and then few, if any, competitors. Then gradually, when your business start growing, then you have a takeoff. Now you start increasing your sales. Now you have a lot of customers. Okay, cost per customer falls, profit rises. So you have increased number of customers, more competitors. More competitors means you have a lot of companies producing the same product. Then again, we have maturity. Then the business will start maturing. So in any company or business establishment, this is how this is the scenario. Okay, so and again, it will lead to a place eventually where you have a maturity. Your business starts, you will reach the highest peak, okay, so to speak, and then you have cost per customer, which is low, and then profits also high, mass market, stable number of competitors. Then again, and for eventually, when the business reach a certain stage and is not able to sustain itself again, then there will be a fall in sales, cost per customer, profit fall, and so on like that. Okay, so here we have a well-designed product, a functional design, a well-manufactured. A well-manufactured product means high-quality product and well-packaged, arriving safely to the customer. Okay, for example, if I want to buy something like a laptop from either HP or any customer, so they need to parcel it. Maybe I buy it online, so they have to send it to me by postal. So the packaging should be well packed, okay, and then it should be safe, arrive to the customer. Otherwise, if the computer arrives and then there is faulty, then it is not good for the company. You see, so their star is going to reduce. If they have 5 star, their star will be reducing to 3. So people will not purchase their product anymore. And then it should be durable, function effectively for its intended purpose. So the product should be durable, it should be flexible, it should be able to withstand, let's say, certain extreme weather condition, okay? And then resource efficient. Okay, the design of manufacturing products, we have number one, design for manufacturing, okay, DFM, integrated process with materials, okay, MFG, methods, process planning, assembly, testing, and quality assurance. Okay, so let's say you want to design a particular product X. First thing is design for, our intended design of this product is for manufacturing. Okay, and then we have to look what are the purpose, sorry, the method by which we are going to produce this particular product. Okay, so then we need to have a process planning, assembly, testing, and quality assurance. So assemble means, let's say if you want to manufacture chocolate, Okay, so there will be a place where the raw material for the chocolate will arrive. Okay, you know, the chocolate is like the raw material is like a fruit, okay, like durian, like this. So we sometimes we need to dry it first. It means it has to be put in the dryer. Okay, then it has to be crushed into pieces. It has to be blended. Okay, add certain elements to it so that it will be edible. Okay, then like this. So it has to go through so many processes. Then the next one is the design for assemble and disassemble. It should be easy to assemble. So the production line should be easy to assemble and disassemble the product. Okay, so let's say if you are manufacturing a product, okay, so it should be easily assembled together, and then we should be able to disassemble the product also. Sometimes you discover that if you buy a certain gadget, it is very difficult to open it. So to, let's say, for its usage, okay? So this should not be there in manufacturing processes. And then design for services. Individual parts, sub-assembles in product, okay, should be easy to reach and service. What we mean by design for services is that, let's say if you buy, let's say my V today, let's say after 5 years, then you start having some problem with engine. Okay, if you have problem with the engine, you cannot bring it to the what do you call it, the tire repairer. You have to bring it to the workshop where the engine can be repaired. Okay, so the individual parts who are specialized in that area, okay, should be able to service it. And then design for manufacturing and assemble, correlation between manufacturing components and the assemble into final product. Okay, so it means here we need to be able to have a correlation between the design, so between the manufacturing of the components and then they are assembled into final product. Okay, so certain products, they are made up of so many components. Okay, something like a rice cooker like this, it has a lot of components, okay, which we have to assemble it together. For example, the casing, the outer casing can be manufactured separately. The heater can be manufactured separately. Okay, and then the thermostat, which is used to regulate the temperature, can be manufactured separately. The cord, the plug, all these things, okay, but it should be able to assemble together. Okay, for example, if you buy again rice cooker, sometimes if after cooking the rice, you need to remove the pot, okay, you remove the plug, okay, so again, if you want to use it, you have to join all these components together before you should be able to use it. Okay, so now product design process and concurrent engineering. In this situation, we say a critical activities such as 70 to 80% of the cost of the product development manufacture is determined by decision made in the initial design. Okay, so this is very important aspect. Okay, so for the product design, so say a critical activities, okay, 70 between 70 to 80% of the cost of the product development and manufacturing is determined by decision made in the initial stage. Okay, so normally if you want to start a business, okay, you need to first plan ahead. Okay, so what is going to be the cost of your product production? Okay, especially 70 to 80% of the production cost should be made in the initial design state. Okay, so that eventually when your product comes into the market, okay, it will not be too expensive for people to buy. Then the design of a product first requires a thorough understanding of the function and the expected performance of the product. So the manufacturer has to have knowledge of the very detailed understanding of the function and the expected performance of the product. So that's why sometimes you have manual. When the product comes, it comes along with a manual. So it means the manufacturer already knows the function, how it operates. So that's why they put it in the manual, so that the customer will be able to understand and then use it. And then the product design involves constructing and studying analytical models through the use of product design tools. Okay, so product design involves constructing. So first thing is that, you see, if you want to design a product, there are various tools that are used to design the product at hand. Let's say if you want to design a particular product, immediately you don't wake up and start manufacturing or start producing it. You need to design it first to see detail, how the the appearance, the physical appearance of the product is going to look like. And there are various tools for doing this. Okay, we have computer-aided design, computer-aided engineering, okay, and then we have CAM, okay, computer-aided manufacturing. So all these things are very, very important tools for the design. Okay, so the CAD technology concerned with the use of computer system to assist in creation, modification, analysis, and optimization. So this is very important, CAD. I think most of you now, you are you know the use of the computer-aided design. Okay, now the CAE is the technology concerned with the use of computer system to analyze computer-aided design geometry. Okay, then the last one is the technology concerned with the use of computer system to plan, manage, and control manufacturing process. Okay, so now product design, process and concurrent engineering. So we have here concurrent engineering, okay, and then simultaneous engineering. So this is an approach where all disciplines are involved in the design stages. So the iteration result is less wasted effort and time. So concurrent engineering and simultaneous engineering involves different disciplines coming together to plan a particular product, integrate the design and manufacturing of products with a view towards optimizing all elements involved in the life cycle of the product. Okay, so a well-organized communication within various disciplines. Concurrent engineering reduces changes in product design and engineering and time and cost from design concept to marketplace. Now we have product design processes and concurrent engineering. Okay, can be classified according to this particular flow sheet or flow chart. Yeah, first, definition of the product. First, you need to identify the product. Then the marketing information should be there. And you need to have idea about market, you cannot just wake up and start producing any product, okay, without having prior knowledge of the market situation. You should know what is going on in the market, okay, how you are going to strategize your product so that in the end, it will be well accepted by the community. Okay, so now the conceptual design, next thing is the conceptual design and evaluation. So conceptual design means it is at the early stage where you use the computer to assist you in the designing. So there is, at that time, there is no physical, what do you call it? The physical appearance of the product. We only have a virtual, or let's say a computer aided design of the product, okay? So, and then we move to the next stage, which is design analysis, okay? Code, standard, review, physical and analytical modes. So we need to assess what are the, what do you call it? The standard, which is guided or which is used to manufacture this particular product. All these things should be known. Then before maybe we can develop a prototype, testing and evaluating. If there is problem, we go back. Okay, otherwise we move again to the product drawing, instruction manuals. You see, these are instruction manuals for the product. Then again, the next thing is the computer-aided manufacturing process planning. Okay, so here also we need to, this is the process through which the product has to go through. We have the pilot production, okay, then finally we have the packaging, marketing, and sales literature. Okay, so and the iterative, let's say, steps for the manufacturing process is this. You have the market, specification, concept design, detail design, manufacturing, and then sale. Okay, so I'll move a bit faster here. And selection, we have selection of materials and processes. See, in every manufacturing process, factors to be considered. There are some factors that we need to consider. Properties of the materials, cost and availability, appearance, service life cycle. When we say properties of the material, so it can be, let's say, if we are producing aluminum plates, what are the properties of the aluminum plates? What is its melting temperature? What is its resistance to rusting? Okay, so so many things, okay, physical properties, specific heat capacity of that material need to be known. Or let's say we are producing a beverage, okay, and a product. So we need to know under what temperature can this beverage be stored so that it will not be wasted, okay? So then the cost and availability, appearance, service, life, recycling, okay? Now, factors to be considered in processing selection. We have selection of process methods. So there are so many methods for production, manufacturing these days. We'll look into all those details later on. Dimensional accuracy, operational, okay, and manufacturing costs, net shape manufacturing, okay, then consequence of improper selection of materials. Okay, so if you do not plan very well to select or for the selection of the processing method, dimensional accuracy, or operational manufacturing costs, in the end you have problem. Okay, so in the end you are going to have problem. So for example, the dimension is very, very important. It has to be very accurate, very, very accurate. Otherwise, if it's not accurate, then it's going to you're going to have a problem. Okay, so for example, let's say, let's take for example the what do you call it? The charger of of a phone. If you want to, let's say, if I'm using Apple charger to charge my Apple phone, if another company is manufacturing the same brand, the same type, Apple charger to charge phone, so the dimension should be very accurate, so much that if I buy from 2, 3, 4 different companies, same charger, it should be able to fit into my phone. Otherwise, if the the charger for company A, the dimension is different from company B, so it will not be able to use. You understand me? So then people will not buy the product because it is not, it does not follow the standard. Okay, so this is very important. And then consequence of improper selection of materials. Yes, I've told you. In the end, you have to stop the product will stop functioning and not function properly, or it may not function properly. Sometimes if you put the charger into your phone, it may not be able to fit into the charger, and maybe either it will be loose, so there will not be contact for the current to flow. Okay, so that's again unsafe for further usage. Okay, so examples of processing selection. We have, okay, casting process. We have expandable, pattern and mold, and others. So this is a molding. This is a molding. You are pouring something like let's say a melting and molten metal, okay, into a particular casting bricks. So we want to manufacture a certain product, okay. So eventually, what can happen is you have lost foam casting. Okay, then we have single crystal casting, and then we have melt spinning processing. So these are different types under expandable pattern. We have expandable mold. Okay, this permanent pattern. So permanent pattern means you have something like a sand casting. Okay, sand casting is this. And then we have shell mold casting and ceramic cold casting. Okay, so permanent mold also, you cannot, let's say, expand, decrease, or increase the system used for the casting. So this is permanent. And then we have die casting, okay, centrifugal casting, and squeezing casting, so on like this. So these are also different examples of bulk deformation process. Okay, so we have rolling. Okay, so we have examples of process selection. Okay, so we have so flat rolling. Okay, then we have shape rolling, depending on the type of manufacturing process that you are involved. If, let's say, your company is such a way that it needs only flat rolling, then no need to go for shape rolling. Okay, because shape rolling may be expensive. Okay, then we have ring rolling. Okay, and then we have roll forging. Okay, so these are different rolling processes. Then we have forging also, open die forging. Then we have closed die forging, so on like this. And then we have extrusion and drawing. So extruding metals, or let's say plastics. Okay, so we have different techniques for extrusion. In direct extrusion, cold extrusion, drawing extrusion, and then tube drawing extrusion. Again, we have sheet metal processing. Okay, these are various metal processing, blanking, we have slitting, okay, punching, and piercing. Okay, so these are various techniques that are available for manufacturing. Then also we have polymer processing. Okay, so these are general information related to polymer processing states. Then again, we have machining and finishing process. Okay, so machining, under machining we have turning, okay, we have drilling bits, okay, so milling, okay, so to cut, okay, plate, make a particular hole in a plate. Okay, then we have broaching also, and then we have advanced machining. Advanced machining, this, okay, so wire, okay, so it could be used for cutting, and then we have chemical machining, okay, so for undergoing, let's say, chemical reaction. Okay, then we have laser machining, a very high accurate machine, laser machining. We have water jet also. Then finishing, okay, surface grinding, okay, and then we have centerless grinding, and so on and so forth. So eventually, these are the finishing part. This is the initial part, and that is the finishing part. Then we have joining processes. So if you want to join two materials together, okay, there are so many ways by using that. We have fusion welding, okay, shield metal arc welding. If you go to the Benkel, the workshop, so if your car is damaged, you bring to the workshop, you see the welding people, okay, joining metals together. We have gas metal arc welding, and then we have flux core arc welding. So other welding available is friction stir welding. So in friction stir welding, we have the tool, okay, moving in between the two plates. So when it moves very fast, so there will be friction between the tool and then the plate. So this friction is going to produce very high temperature, which will be enough to melt the edges of the plate. And then eventually the melted surfaces are brought together, and then it will form one component. So we have also resistance welding, and resistance welding means that you have a tool, okay, one on each side, and then the product will be passing through them. So again, there will be a high temperature developed, which eventually bring the metals together. Okay, so these are various types. Now, role of manufacturing in nation economy. Let us look at the role of manufacturing in nation economy. First, gross national product. So in every nation or in every country, okay, the economic of that particular country depends largely on the role of manufacturing, the ability of the country to manufacture its own products. Like Malaysia is manufacturing oil, Malaysia is also manufacturing, let's say, oil and gas. Malaysia is manufacturing so many different products. If Malaysia has got gold, diamond, timber, and they are manufacturing all these particular products, then eventually the economy of Malaysia is going to increase. okay, because they have to export this product to other countries for them to buy. Understand? So, and the GDP, or the gross national product, is very important. And we say this GDP, sorry, gross national product, GNP, is the market value of all goods and services. A market value of all goods and services produced in 1 year by labor and property supplied by the residents of a country. Okay, so the gross national product is the market value of all the goods and then service produce. Okay, services used to produce the goods. So let's say if Malaysia is manufacturing, let's say, for example, palm oil. How much tons of palm oil is produced per year? And what is the value of the service which is used to produce the palm oil? If you quantify all this in monetary value, so it can be billions of ringgit. For example, Malaysia's economic growth accelerates to 4.7 in the quarters. Q4 means quarters. Okay, let's say the quarter of the year, right? So, and then in 2018, okay, so let's see over here. This is, so you see here we have 5.6. 5.6, this is the GNP, or the Malaysian growth economy. So eventually, so it increased, let's say the following year, GDP increased the following year, and then so again increase up to 6.2, then it drop, then it starts to increase again. Okay, and so it means if you have more high GDP, it means your country is doing very well in terms of production and let's say services. You understand? Very important. So now, again, GDP of the economy, okay, activity should be like this. We have economic activity, services such as mining or manufacturing. So let's say the economy, the share, services forms about 56% of the share of the GDP. And then manufacturing, 22.8. Construction, 4.2. Mining, 7.9. Agriculture, 7.9. Okay, so these are all the economic activity. So services means that, let's say you bring your car to the banker, it's a type of service. Or let's say you have a cleaning company which cleans all the floors in your ATM. This is also providing services. Or let's say service air condition for, let's say, TMB company. So this is also servicing. So servicing form a very large share of the economy activity. Okay, so then the growth, the growth is about 3/4, so it's about 6.9. Okay, and then up to 7.2. Then manufacturing also forms about 22.8. Manufacturing means your company is manufacturing beverages, chocolate, drinks, different things. Then we have construction. So let's say your company is involved in constructing buildings, or let's say in constructing houses, okay? So, or rentals like this, okay? Now, the GDP by types of expenditure is given over here. The type of expenditure: private financial consumption expenditure, okay, attributed by food and beverage, communications, restaurants, and hotels. Okay, so the GDP growth about for private financial consumption expenditure forms about 8.5%. Then we have gross fixed capital formation. It forms about 0.3%. So then next is the government final consumption expenditure. Okay, so this is spending when the government is spending money, okay, for particular services and so on. Okay, then we have exports. Export forms about 1.3, and then import, okay, 0.2. So this in a way is good. So if the export is much more than the import, this is a positive scenario, because exporting means that so you are sending goods outside and then money is coming into the system, okay, and this is good for the country. But on the other hand, if you are importing, it means that money is leaving the country, okay, instead goods are coming in, maybe very expensive goods. Okay, so that 0.2, it means that this is a good situation. So now let us look again at the manufacturing in December 2018. Malaysia's manufacturing sales grew, so grows about 7.5% in December 2008 to 72.3 billion. Okay, so let us look at the various sectors. We have sale value. A sale value constitutes 72.3 billion, and then number of employees. Okay, so we have about 1,075,635 persons. Okay, so this is the number of employees involved. Those means those who are working. All right. So now the salary wages means amount of money you need to spend to pay the workers. All right. So this is about 4 million. Okay. So again, this constitute about 10.1%. Right. Then we have the sales value per employee. Okay, so sales value per employee is about 67,249, right? So all these things, if you bring them together, it gives you about, so if you compare 2007 to 2018, you see that there is an improvement in 2018 compared with 2017. Okay, so now let us see sales value of 7 sub-sectors. So now we are going individually, the sale value, okay, or the value of each particular sector. For example, let's start with transportation, transport equipment, and other manufacturing. Okay, that forms about, in November 2018, that forms about 9.1%. Whereas in the food, beverage, and tobacco industry. This forms 2.7. Okay, then we have textile industry. Then we have, let's say, wood, furniture industry. And then we have the petroleum, followed by non-metallic material products. And then we have electrical and electronic products. So you see, electrical and electronic product constitutes a very high percentage because of what? The awareness in electronics and the Internet of Things like this. So, and this type of business now is booming. Okay, so if you have the opportunity to enter into this business, then there is a high chance of the business to survive. Okay, so now let us look at the Malaysian Industrial Production Index, IPI. This increased by 3.4% in December 2018. So Industrial Production Index is a measure of the rate of change in the production of industrial commodities in real terms over time for manufacturing, mining, electricity sectors. Okay, so in every industrial product index, say that it's a measure of the rate of change in the production of industrial commodities. So how often do they change? Okay, that's the product. Okay, so if we look at IPI for example, mining, okay, so this forms about 1.1%. Okay, so manufacturing, 4.4%, electrical or electricity, 2.7%. Okay, so and then under manufacturing, we have electrical and electronic products, petroleum and chemical products, transport equipment. Okay, then we have under mining. So these are very sub areas. Okay, so related to individual IPI, that is Industrial Production Index. So then this industrial production is a measure. It's measured based on the volume changes in production. So IPI gives the overview of the current trend of industrial activities and used for economic analysis. Okay. Now let us look at sustainable development. Sustainable development goals. When we say sustainability is a very important area in which cuts across so many sectors. Okay, so sustainable development means that you are able to sustain a particular business for quite a long time so that the future people will also benefit from it. Okay, so number one is that there shouldn't be no poverty. Okay, so this is a goal for when we say sustainable development, then we should eradicate poverty. Means there shouldn't be any poor person in the community. And then there should be zero hunger. Okay, so means everybody should be able to at least afford food. Then good health and well-being. So there should be good health, so everybody should be fit, and then quality of education, gender equality, male and female are equal, okay, in so many terms. And then number 6, clean water and sanitation. So it goes on like this: affordable and clean energy. Okay, so these days, the environmental concern is really creating awareness so much that people are now moving from conventional way of energy production to renewable energy. So this is what we really mean by clean energy. Clean energy means using an energy which eventually also producing an energy which eventually does not harm the environment. For example, solar energy, wind energy, tidal waves. Okay, so these are renewable energies. Then we have decent work and economic growth. So all these points leads to what we call sustainability. Then we have climate change or climate action, life, okay, below water means we need to take care of the fish. We shouldn't pollute the ocean. Okay, life on land also should be safe, peace, justice, and strong institutions. Okay, so there shouldn't be corruption in any institution. There should be peace, there should be justice. Okay, then partnership for the goals. So these are very important areas to ensure sustainability of a particular country. Then we have sustainable development goals. Okay, in sustainable development goals, progress of goal 9 in 2018. So, and in order to come out with the progress of goal 9 in 2018, we have the global share of manufacturing value added in GDP increased from 15%, 15.2% to let's say percent in 2005 to 16.3% in 2017, driven by the fast growth of manufacturing in Asia. Okay, so this is giving us the overview of the sustainable goal, goal number 9, okay, in 2018. Means that, let's see over here, this is the goal number 9, industrial innovation and infrastructure. Okay, so you see the GDP increased from 15 to 16%, and it is because of the goal number 9. Globally, the carbon intensity decreased by 19% from 2000 to 2015, from 0.38 to 0.31 kilograms of carbon dioxide. So these are the events that took place that led to the progress in goal number 9. Okay. Now, progress of goal number 12 in 2018. Let us look at goal number 12. Goal number 12 is concerned responsible consumption and production. Okay. The per capita material footprint of developing countries grew from 5 to 5 metric tons in 2000 to 9 metric tons. Okay, so, and then for all types of materials, developed countries have at least double the per capita footprint of developing countries. Okay, so these are very important areas. Then we have sustainable manufacturing. Okay, sustainable manufacturing can be defined as a method of manufacturing that minimizes waste and reduces the environmental impact. We have low resource production costs, lower regular compliance. Okay, key benefit from sustainable manufacturing. Okay, so improve sales and brand recognition. Say great access to financing. So it means that you have access to, let's say, if you want to take credit from the bank should be willing and to able to assist you. Okay, and easier employing, hiring, and retention. Okay, and then sustainable again. Why companies are pursuing sustainability? The reason is that increasing operational efficiency by reducing cost and waste. Okay, so we need to increase the efficiency of our production, and then at the same time, uh, reducing the cost. Okay, and then respond to or reach new customers and increase competitive advantage. So all the time you should be on the way looking for new customers. Okay, for example, Malaysia is highly well known for producing what do you call it, palm oil. So you can export your palm oil also to other countries like Africa, okay, Europe, America, and so on, like this. So you should increase your uh, customers like this. And then build long-term business viability and success. Respond to regular constraints and opportunities. Then ways that companies progress further on the path to sustainability include addressing sustainability in coordinated, integrated, and formal manner. Focus on increased competitiveness and revenues rather than primarily focusing on cost cutting. Okay, so you see, for sustainability, we need to focus on competitiveness and revenues. Okay, so competitiveness means the product should be of high quality. So if company A, B, C are producing the same material, so then they should be make sure that the standard is maintained, quality of the standard is maintained, okay, or improve upon the quality. Sometimes you buy product A from company B, but the quality is different. Okay, so again, this is not good for sustainability. Now, tools to implement sustainable manufacturing. Tools use the life cycle assessment, okay, an approach to examine fully the environmental impact of different activities performed. Steps in life cycle activities. Define appropriate scope. What is the scope of the product and its limitation? And develop a quantitative analysis of the material and energy inputs to the product or process at all levels. Okay, so let's say you want to manufacture, let's say, a palm oil. Palm oil, so for cooking. So first, how much? So we need to go to the farm to cut the fruit first. How much energy? Okay, when I say energy, the fuel consumption for the machine to cut the fruit. What is the energy consumption? What is the cost? And then the labor, all these things need to be calculated. Okay, so then develop a quantitative analysis of the material and energy input to the product. Okay, so what is the energy input to the product? We have to know all this. Relate the output of the system at each stage to direct impact on the external world. Okay, so eventually when you produce the palm oil, is it going to cost you? Sorry, how much are you going to sell it to the outside world? Based on the cost that you have incurred. Okay, so but we have to ensure that minimal cost is incurred during the production of the material. All right, so we have some more time. Okay, so we need to finish up to a certain stage. You have to bear with me. Okay, so let's move on quickly. Now, Sustainable manufacturing has various steps. Okay? Increase circularity in manufacturing to reduce utilization of resources so that less material is extracted from the earth. Okay, so in order to make a sustainable means this approach is more or less like recycle. Instead of throwing the raw material, which is as a waste, it can be recycled and then reused again. Okay, so the first thing is we have to RO is refuse. So to refuse, to number two, rethink. Number two, RO is refuse. Okay, it means make products redundant by abandoning its function or offering the same function with radically different products. So it means RO1 means you should not, let's say, make a product redundant by abandoning its function. Okay, sometimes if you go to the warehouse of some companies, you see that, oh, some my products have been left in the, let's say, in the yard for a long time. It has been rejected and it is not being used. So this is not good. You should refuse it. And then rethink, make products use more intensive. Okay, so by sharing products. And then R2, reduce, that is increase efficiency in products, manufacturing or use by consuming fewer natural resources. And then R3, reuse. Reuse by another consumer of discarded products. So all these things are up to R9. R9 means recover. Okay, so incineration of material with energy recovery. Okay, so see, incineration plant, an incineration plant is a plant which is used to burn refuse and then to produce either energy. Okay, R8 is recycle, processed material to obtain the same high grade or low grade quality. So they can recycle the same product like this instead of throwing it away. And so these are very, very important. So it means increasing circularity. Circularity means recycle. Okay. Now, activities introduced to achieve sustainable manufacturing. These are various activities. Okay, let's start with this: sustainable design, supplied attitude and support for sustainability, customer attitude and support for sustainability. Is the customer prepared to sacrifice his or himself to follow the rules for sustainability? This also is very important. Environmental control, monitoring, and remediation. And then we have community engagement for sustainability. Sustainability indicators, policies, and procedures. Right? So now we have environmental conscious design. In environmental conscious and manufacturing, we have lubricants and coolant for machining. So if you go to the automotive industry, okay, in the engine, we have lubricants. Lubricants are used for, let's say, reducing friction among moving parts in automotive engines. And then we have coolant also. These days we have, you see, in the car radiator has a fluid. Sometimes lots of people put water. So other car users also put, let's say, a special coolant, special fluid, okay, into the refrigerator, sorry, into the car radiator. Okay, so all these things are highly poisonous fluids which can really affect the environment. So again, recently, even in Johor Bahru also, there were some company, they just discharge the waste oil into the river, and it's affected a lot of aquatic life. Okay, even eventually it affected, let's say, plants. Okay, so animals were affected. Okay, so this is not good. We have to try to bring ourselves, okay, to be responsible so as to avoid polluting these rivers, drains, and so on like this. Okay, so this is a typical example. So recently again, in Selangor, some people just put waste oil into the river, and it affected all of us. We couldn't get water for some days. No, so this is not good. So environmental conscious is very, very important. Metallic and non-metallic scrap should be properly treated. So major concern, water and air pollution, acid rain, ozone depletion, the greenhouse effect, hazardous waste, and global warming. So these are major concerns when it comes to environmental environmental consciousness. Also, certain guidelines can be followed to reduce the risk, reduce waste of materials. So every company needs to reduce so many wastes. If you produce so many wastes, then you are more likely to, again, discharge your waste into the river or into the environment. And we have to reduce the use of hazardous materials in products and processes. Okay, and then conducting research and development into environmentally safe products. Okay, so these days, go to Giant, they have a special plastic, and this plastic that they put into your, it can easily decay. Previous plastic, there are certain plastic, it will stay for so long years before it will start decaying. Okay, so most especially, packages should be, best packages should be, let's say, paper. Okay, so now ensuring proper handling and disposal of all waste is also very important. Now, design for the environment or green design. So we have to make sure that our manufacturing system is designed such a way that we anticipate the possible adverse environmental impact of material, product, and processes, so that it can be taken into account at the early stage of design and production. So at the early stage when you want to start your business or your manufacturing process, okay, you have to have environmental consciousness about your product. Okay, so what are the guidelines that you need to follow in order to avoid any pollution, okay, into the environment? So you have to, all these guidelines. For example, if you are the one who make a servicing for automotives, like the banker, mostly a lot of people bring their cars to change the engine oil. So this engine oil has to be properly kept in a safe way in which it will not be discharged into the rivers or drainage. Okay. Now, let's look at industrial revolution. Okay. So if we look back so many years ago, the first industrial revolution Okay, it's about introduction of mechanical production facilities supported by water and steam power. So you see, we are in the previous years we were using locomotive train. Locomotive train means that we have, let's say, water is boiled in a boiler, and then from this water, so a pistons move up and down, and the movement of this piston drives the train, okay, to whatever distance it wants to go. So this is the first industrial revolution. The second industrial revolution is the mass production fuels. Okay, that's the second industrial revolution with the help of electrical power. So first we move from mechanical production facilities to electricity. So there was, in the first industrial revolution, there was nothing like electricity. Everything was based on mechanical movement. I've told you, internal combustion, okay, the locomotive, when the train wants to move, so we burn fuel, and then out of these fuels, high, very superheated steam is produced. Then the steam pushes the piston up and down, and then it is able to move the train up and down. Now we have electrical, and the second revolution, we have electricity. So the electricity is able to do so many jobs. Then third industrial revolution, we have IT, that is internet. And then the final industrial revolution, the fourth industrial revolution, maybe we want to have a fifth industrial revolution in future. The fourth industrial revolution is the use of internet of things and like this, robotics and so on. Okay, computer integrated manufacturing capabilities refers to responsive to rapid changes in market demand and product modification. So now we are in the era of computer integrated manufacturing. So it means every manufacturing process that is integrated with a computer system. So better use of material, machinery, personnel, and reduction inventory. Okay, so the manufacture of high quality products at low cost. So this, if you use computer integrated manufacturing, then you are likely to have a manufacturing of high quality product at low cost. Okay, so because there are certain guidelines, certain standards which the computer can guide you. If you are having a problem with your product, immediately it will prompt you. You understand? Okay, so the major applications of computers in manufacturing. What are the major? So these are very important questions which can be asked in exams. What are the major applications, okay, of computers in manufacturing? Number one, computer numerical control, adaptive control, industrial robots, and then we have automated handling of materials. Okay, so then we have number 5, computer-aided process planning, okay, group technology, a just-in-time production, cellular manufacturing. It goes on like this: flexible manufacturing systems, expert systems, artificial intelligence. Okay, so now industrial revolution 4, IR 4.0. So that is the latest trend now. So IR 4.0 is related to what is called the smart manufacturing. Okay, so in a smart factory, a virtual copy of the physical world and decentralized decision making can be developed. Also, physical systems can operate and communicate with each other and with humans in real time, all enabled by the IoT and related services. So the concept of Industry 4.0 has its origin in Germany. So Germany was the first to initiate this. and has been recognized by other leading industrial nations, although it is known as connected enterprise in the United States and the fourth industrial revolution in the United Kingdom. Okay. So Industry 4.0, these are the various steps. We have first big data. Okay, big data means all the manufacturing processes there is data available for it. This data will be fed into an automatic system or robot, and then there will be simulation, and then the system will be integrated with the simulation. Then we have internet. Then cyber security also comes in, cloud computing. Okay, you can be here and then you can be operating your system, let's say in another country, like this, cloud computing. And then adaptive manufacturing, augmented reality. So these are the main element of Industry 4.0. Okay, so shortly we will stop very soon. Why do we want to go into Industry 4.0, or why is it important? Okay, here are just a few of the many reasons which Industry 4.0 is so important to the future of manufacturing. Number one, flexible and data-driven production process. Okay, so Industry 4.0 is very flexible and data-driven production process. Will foster innovative and enable mass customization. Okay, and then Industry 4.0 is also is that smart products will allow the manufacturer to understand how products perform in a customer environment. And then it enables high productivity. Okay, and then digitalization of the entire value chain will lead to upgrade of entire sectors. Okay, so major Industry 4.0 initiatives are happening in industrial centers around the world. Okay, so for example, in China, Japan, Germany, Brazil, just to name a few. Okay, so virtual technology. In virtual technology, we have virtual reality. Okay, so immersion in virtual worlds. Okay, so you immerse yourself in a virtual world. So be thinking about something which is physically not present, but in real in a virtual sense. Okay, so and then we have mixed reality. Okay, so we can have the physical object and then combine with the virtual, and then augmented reality. Okay, so again, this is tuning or connecting internet to the gadget. Okay, virtual on top of reality, limited interaction with the virtual, smartphones and tablets. Okay, so these days you can use your smartphone to order food from outside. Okay, Food Panda. Okay, so virtual reality implies a complete immersion experience that shuts out the physical world using virtual reality device such as HTC Vive, okay, Oculus Rift or Google Cardboard. Okay, users can be transported into a number of real world and image environments, such as middle or quacking, okay, and this. Then we have mixed reality. Mixed reality brings together real world and digital elements. So real world and digital elements is the mix. In mixed reality, you interact with and manipulate both physical and virtual. So it's sorry, with virtual items and environment. Whereas in the augmented reality, it adds digital elements to a live view, okay, often by using the camera or smartphone, augmented reality. Okay, so just like we are having our, what do you call it, lesson now online, this can be referred to as augmented reality. Okay, because you can, in real time, we can have a chat, okay, interact with each other, either through the phone or through the computer. So important areas for uh, the technology. Okay, we have production, importance of virtual technology, production floor planning, predictive analytics and big data, increase productivity and efficiency, training new workers, enhance safety inspection, and inventory management. So these are the main elements for industrial technology and, virtual technology. Application of virtual technology. It can be in the health services, hospitals, okay, chemical industries, in the film and television, virtual travel, professional sports, and gaming, okay, like this. Now, virtual technology in manufacturing, virtual reality in industrial manufacturing. Okay, so here we mentioned that virtual augmented reality improving training and communication methods in the workplace. So we have 39% of large companies use virtual augmented reality to enhance ability for employees to train in simulated environment. Whereas 41% of large companies use virtual and augmented reality, and 11% of large companies don't use virtual augmented reality. So you see that a large proportion of the companies now are moving towards this virtual reality. Okay, only a few companies are left behind. So virtual technology in manufacturing. Okay, so we have some videos over here. Let's see. Okay, so this is the first video. The second video also related to manufacturing. Okay, the last video is this. So, and that's the overview for the video. Okay, so now we see how very important virtual manufacturing is. It is going to help a lot, especially for those working in the automotive industry. So if the human beings are replaced by the, what do you call it, by the robot, then it will help a lot because they will not be they will not be exposed to safety or a risky environment where the workers can get hurt or they can have accident in the workplace. Okay, so the impact of virtual manufacturing, okay, has a large impact on services and business models, okay, reliability and continuous productivity. Okay, in IT services or security, companies like such as SmartTech, Cisco, and Penta Security have already begun to address the issue of IoT security. And then machine safety, product lifecycle, industry value chain, workers' education and skills, and social economic, very important aspect. Now, competitiveness aspect in manufacturing, you have global competition, okay, market conditions fluctuate widely, and then customer demand high quality, low cost products, and on-time delivery. Okay, so the competitiveness aspect of smart manufacturing is now is moving towards a very good product services, high quality product. Okay, product variety increased substantially, and then products become complex, and product like life cycles became shorter. Okay, so these are the various impacts. Okay, so the general trends in manufacturing are important trends: materials and process, manufacturing pro system, organizational trends. Okay, so these are key important trends that affect manufacturing. For a manufacturing enterprise to be successful, it must respond to the following: view the people in the organization as important assets, emphasize the importance and the need for teamwork and involvement, problem solving, and in decision-making process in all aspects of operation. Also encourage product innovation and improvement in productivity. Okay, so increase flexibility, encourage effort for continuous improvement, and ultimately, more and most importantly, focus on customer satisfaction on global scale. And then the design principles for economic production. The design should make the product as simple as possible to manufacture, assemble, okay, and then disassemble and recycle. Okay, so so there should be a waste reduction in the smart manufacturing or the economic of the production. To be viable, there should be waste reduction. And the material should be chosen for their appropriate manufacturing characteristics. Okay, so the materials must be well, chosen so that there wouldn't be any waste or redundancy. And then the dimensional accuracy also need to be taken care of. And then the net shape as well. Then lean production. Lean production is a methodology that involves a thorough assessment of each of the activities of a company in order to minimize waste at all levels. Okay? So each company needs to have a thorough assessment of each activity maybe Proton. In Proton company, they have so many areas or activities. They have people with fixing the body, people concerned about the internal combustion engine. There are some people also specialized for radiator in the car, and so many things like this. Okay, and this requires a fundamental change in corporate culture, as well as understanding of the importance of cooperation and teamwork among management. Okay, then we have agile manufacturing. Implementation of the principles of lean production. So the lean production primarily is to reduce waste in every activity of the company. Reduce waste as much as possible. Okay, and this requires a fundamental change in corporate culture, as well as understanding of the importance of cooperation and teamwork. Without teamwork, there wouldn't be any profitability. So in agile manufacturing, the implementation of the principles of lean production on a broad scale, the principle ensuring agility or flexibility in the manufacturing enterprise so that it can respond rapidly to changes in product design or demand and customer needs. Okay, so then we have also product improvement through value engineering, okay, a systematic method to improve the value of goods or products and services by using an examination of functions. And then value as defined is the ratio of the function to cost. Value can therefore be increased by either improving the function or reducing the cost. So you can increase the value of a product by increasing or improving the function, that's the efficiency, or reducing cost. Value engineering, a technique in which the value of systems output is optimized by crafting or mixed performance. Okay, so in most cases, this practice identifies and removes unnecessary expenditures. Okay, and these are examples of product improvement through value engineering. Okay, so if you look over here, you have the rice cooker over here, all are made up of Panasonic. Okay, so here you just push the button down. It doesn't tell you whether it is cooking or not. But here we have the red indicator and off. Okay, here when you press the button down, it will it will be red, the light will be red. Then it will say, oh, it will give you the indication that now the rice is cooking. After it has finished cooking, then the red light will go off. Now, here they have a digital, okay? Here you can set, let's say you can set the clock, okay? You can set the time or keep warm timer, the minutes, cooking time, okay? Let's say 10 minutes, 15 minutes. After that, it will be off. Okay, so these are the improvements. I think we have come to the end of this class for today. Okay, so we will be discussing these questions later on, okay, in our class. Okay, but for now, I would like to stop over here. Okay, is there any questions so far from anybody? Let me know. Yes, is there any question from any of you? So,
all the time. Yeah,
What?
so
Is there any question? Hello?
we don't have any question. I mean, I don't have any question for
Okay,
the
okay.
first.
You don't,
Yeah.
because of what? You said you don't have any question, right? Okay, so and then inshallah, I think we will meet in the next class. Okay, so thank you very much.